Okay, Josh, some more tests. The first one, P-series test. It's pretty simple. You get the series sum from 1 over, I say, n to the p. As long as p is less than or equal to 1, then the series is going to diverge. And as a matter of fact, this constant on the top doesn't matter. It could be 10,000. If you have 1 over n squared, P-series would say converges. What that means is it adds up to a finite number. So if I multiply that by 10,000, it's still going to converge. All right, so P-series test, pretty simple. The next important one is this limit comparison test, which I'm going to read to you. But essentially what you say is, if I know some series converges, um, and I test another series, I take the limit of the ratio of those two. And if it's a finite number, then that series will behave just like the original one. So I'm going to give you an example of the limit comparison test here. On the first worksheet, you're going to get this number 5. So I have root n over n squared plus 1. Now, I want to get that n out of the numerator, so I divide top and bottom by root n, and see the bottom is going to be n to the 3 halves plus something else. Once I have something, a constant over n to the 3 halves, I know that is going to converge by the p-series. So in this one, what I would do is do the limit comparison test to the original series compared to 1 over 3 halves. And I'm going to get a finite number, which is 1. Once I have that, since I know 1 over n to the 3 halves converges, this series converges. Um, the where is it? The integral test, which is on this sheet, is not used that much. You could take a look at that, but just be aware of that. The ratio test, I don't know if we've gone over that one yet, but we've been talking about that quite a bit in class with the second part. That is a pretty important test which I can talk to you about in class. And the last test you need to know is the alternating series test. So all of these tests we've been talking about up to this point, all the terms are positive. Once I have a series that goes plus, minus, plus, minus, plus, minus, I have a different test I apply. All I have to do is show that the limit of the a sub n's goes to 0, and then I have to show that the terms decrease. So on this worksheet, number 1, which I hope you can see there, is an alternating series, which I can tell by the negative 1 to the n plus 1. So then I have to look at the a sub n's, the 1 over ln of n. Does that go to 0? And clearly it does as n goes to infinity, so I have my second condition met. And then for the decreasing terms, something like what I just showed you here. 1 over ln of 2 is less than 1 over ln of 3, which is less than ln of 4, etc. So by the alternating series tests for convergence, this series converges. You'll see the same thing with number 3 there. The only caveat I'd say with the alternating series is you still have to test the a sub n's for the nth term test. So if I had something, I don't have one here, but if I had the a sub n's that went to 1/2 or something like that, as n went to infinity, that would diverge by the nth term test. But if the terms go to 0 and they're decreasing, then you've got convergence. All right, that should be enough to get you through most of the next 2 sections.